My name is Fatih. I'm a data scientist coming from a mathematics, statistics, and economics background. So I'm going to talk about LDA topic models today. A little bit of background of how I got to know LDA topic models. I actually saw it on a job posting by Booking.com. So I was just curious and I wanted to learn it. And I learned it and I wrote an article on that. Put that on my LinkedIn profile, and later on I saw that that article got received by the data science community with pretty high interest. I saw a few blog posts citing it, people shared it, and the well-known Python package on LTE topic models called Gensim, that official page, tweeted that article. So I decided to present this interesting subject to you today. So as we all know, we are living in a different world. We're living in a world of big data, right? And as IBM puts it, it has four V's. Four V's characterize the big data that we have today. Volume, we have incredible amounts of volume today. Solely Wikipedia can dominate maybe a bunch of encyclopedias summed up together. We have variety different forms of data. We have audio data, video data, text data, sensor data, right? All kinds of data. And velocity, this data flows extremely fast. And veracity, the uncertainty of data, the data is not clean, right? It's always dirty. It comes with like irregularities in mess. So today I'm going to talk about text variety of big data, which really flows very fast. Just an example, log into your Twitter page, just look at the tweets that you see, wait for 60 seconds and reload the page. You'll see that you'll have to scroll the page twice to reach the tweets that you saw just 60 seconds ago. So it really flows that fast, as you all know. And veracity, especially text data, is very dirty because not everybody is really good at grammar, right? We make grammar mistakes when we speak, when we write, sometimes intentionally, right? So we, in order to process that text data, we need an algorithm that can cope with veracity of that text data, which flows very fast and which is huge, right? So we want to act upon the insights we derive from that text data. But the problem is we can't read all of this data. It's too big. That's why we need an algorithmic reduction technique so that we can reduce any text document that we see into insightful characteristics, such as the sentiment of a tweet, right? I don't have to read each tweet that people tweet about my product. What I need is like the average market sentiment at a location maybe, right? Or at an age group maybe. We are interested in an email being spam or not without reading the entire thing. And we are interested in what the online reviews for a product or service are talking about, what people are saying, because we can derive incredible value from that, which is what topics the online reviews are referring to. Hence the name topic modeling. So why are we interested in this? Let me talk about the business implications real quick. We can build much better recommendation systems. And indeed, that job posting that I saw LDA topic models for the first time was because they had incredibly sparse data, right? Think about travel data, like how many times did you leave a review to a hotel? How many times do you even book a hotel on, say, Booking.com or Expedia or whatnot, right? Once a year, twice a year, I would bet not more than 5 times a year. So it's extremely sparse. So there are these points that you have data, and then there are these tens of more points that you don't have data. That's why you need this kind of an intelligent way of capturing those reviews. And indeed, these two surveys are really interesting because they underline the importance of customer reviews in people's buying and purchasing behavior. Secondly, we can use this in search engine ranking, right? If we know what topics a web page is talking about, we can better rank that in our search engine. Thirdly, we can use this in market research, sentiment analysis, in marketing, or even in politics, right? So you want to measure how people think about you after certain incidents. So that's why you need this. And thirdly, financial planning. The cited paper here is from my PhD supervisors, Nathan Balke. This is a very interesting paper because what they find is, by just looking at a text document that the Federal Reserve System publishes, you can basically capture all the economic indicators before those economic indicators are published. This is pretty interesting paper. And actually in 1998, he published his first paper on this topic where he would just take a pen and he would basically label each and every word with plus, minus, right? The economy is gonna be good or bad. And then he would take the average of those plus minus scores that he would assign by hand. And that would basically Granger cause the GDP growth, the unemployment, and whatnot. So later on, this paper, they are using text mining techniques, doing things in much smarter way, which is, of course, more desirable. So let's talk about finding topics of a document. So our goal is, given a collection of text documents, we're trying to figure out what topics each of these documents are about, right? That is, we want to label each document with the topics they are associated with the most. Now, there are intersections on these, right? There are overlaps. We never observe one document or one speech or one image or anything to be related to only a single thing. A picture might involve ladies, men, like different objects, different landscape, right? It's about many things. And so is topics. So in order to do this, to label each document with the topics they are associated with the most, the first question is, do I have a labeled training data set? Now, this is a very important question, which I will explain in the next slide. Now, assume that we are given a huge library, right, with all the books labeled with subjects or topics. We say, okay, the top shelf is mathematics books, second shelf is statistics books, economics, law, and fiction. And then you're given an unseen book that you're asked to classify into one of these, right? This is very easy. You can basically build many models on this. You can go multi-class, multi-label, however complex you want to be, right? Since we know these labels, we can basically apply discriminative models, which we mostly use for classification purposes, and basically we are good. But the problem is, what if our library has no topics, right? We are only given a bunch of books, say thousands of books, with no labels. And we are given a new book, and we are asked to tell what topics this new book is. Now the problem is, well, I don't have anything to compare it with, right? I mean, if I had like labels like this, I could at least like look at the words and stuff. I could kind of relate it with one of the labels, right? Like build some kind of proximity or some kind of classification model. But if we don't have that label, what do we do, right? What do we do? What if we don't even have a list of possible topics? Right? We're not even given that, hey, just so you know, your labels can be math, statistics, economics. We're not even given this. Basically, we're not given anything. We're just given documents to classify into topics we don't know what topics are, we don't know what possible topics exist, we are clueless, right? So what do? Of course, we don't just sit and start crying, right? We have solutions. Generative models to the rescue. Now, generative models are different than discriminative models that we just discussed, which we most of the time use, like maybe 90%, 95% of the time, we use some kind of discriminative model where we have labels and training data set, and we can kind of infer each data type. So they estimate the conditional probability or the posterior distribution of Py given x, where x is the input data and y is the label that we want x to classify into. And whenever this Py given x, say Py1 given x is greater than 0.5, we're going to say, okay, x falls into the label y1, right? But the generative models work the other way. They estimate Px given y and Py, or equivalently in Bayesian terms, they estimate the joint probability of data and labels. Now, this might really sound magical, and if you work through the math, you indeed see that it is magical. So the mindset is 3 items. 1, there are dynamics that generate data, right? We don't randomly put words next to each other and claim that this is a sentence. Every sentence that we say or write is coming from some kind of lexicon, right? It's coming from some kind of structure. So we believe that there are dynamics that generate data. And the goal is to model this data generative process. And bullet point 2, those dynamics combine to generate the observable sample. Whatever we see, whatever book we are holding in our hand right now is kind of generated by some hidden factors that we don't observe. But we can estimate its joint probability function using these techniques. And the third part of this mindset is we ask the question, which category is most likely to generate this signal or instance? Now compare this with the question of discriminative models. We would ask which category is associated with the data that I am holding right now. Here we're asking which category is most likely to generate the data that I'm having. So these categories are actually generating the data. The data is not only falling into one of these categories. So examples of this are listed here. I'm sure you're all familiar with naive Bayes. This is maybe the simplest form of this. And we have mixture models, hidden Markov models. These are all very cool techniques, highly mathematical. And I'm going to talk about the LDA topic models. I promise it's going to be just a gentle talk. I'm not going to go into the details. I will just talk about the intuition, how things work, and its significance. So let's define what a topic is first. Topic, in the context of LDA topic modeling, is not a single word. We don't have a topic such as sports or fruits or whatever, like cars. We don't have those topics. Topics are a distribution of words. And we infer that this distribution, this particular distribution, could be named as one, with just one word. 2 examples, 45% soccer, 35% running, and 20% ping pong, right? So what we see here is a distribution over 3 words. This is a topic. And we can easily call this the sports topic, right? That's the naming that we give to this topic. And the second example is apple, banana, apricot, mango. We infer that this is fruits, right? So if a book is talking about apple, banana, apricot, mango, we infer that the topic fruits is in this book, right? And there are many topics that are covered in each text document. So words These words, soccer, running, ping pong, apple, banana, apricot, mango, they come together according to a recipe, which is called multinomial distribution. I am not going to give any detail or something, not to scare anybody here. And these words generate topics, the topics that we see here. And at the same time, to follow along that process, these topics are generative processes themselves, and they themselves generate the text documents that we have in our hand, that we observe, right? So words generate topics, and topics generate text documents. So let me describe to you how my talk right now is generated, right? So we have a vocabulary. This is a huge list of a finite list of words that starts from abandonability, about, goes all the way up to the letters that start with Z, right? So this vocabulary, the words in this vocabulary come together according to distribution, and they generate a bunch of topics, right? Millions of topics that you can think of. Just to name three, algorithm, statistics, and mathematics, a composition of these three words could be inferred as the machine learning topic. Marketing, advertisement, and customer could be inferred to be the business topic. And meow, furry, milk, and spontaneous could be inferred to be cats, right? Because cats are spontaneous. So this is how vocabulary generates topics. Now, these topics come together according to another recipe, which is called Dirichlet distribution. This is a probability distribution. And these topics, according to this recipe, generates the document, which is my talk right now. So, and when you listen, just listening to me, you can infer that my talk consists of mostly of machine learning and a little bit of business too, because I mentioned about marketing implications of topic modeling as such. So this is basically the general structure of LDA topic models, and the only thing that we observe is this. The only thing that we observe, that you guys are observing right now, is the talk, right? Or the text version of the talk, right? So that is the model. Any questions, Marielle?
What's the last kind of distribution on there? Back up the arrow.
Yeah. So this distribution was like 80% machine learning, 20% business. And pay attention, it doesn't contain all of the topics that we can think of, like millions of topics that we can think of, because it's not possible to talk about everything in one talk or in one text document, right? So some words are associated more, they cluster together more usually, and that's how they form the topics. And some topics come together more often to generate any kind of text document.
So what's that arrow, that last arrow?
Dirichlet distribution.
What is it?
Dirichlet distribution. LDA. If you search LDA models, Latent Dirichlet Allocation models. So I made an application of these models. So I got data. This is publicly available from this link. And what this data is, this is a collection of text reviews for more than 12,000 hotels in separate JSON files. I used Python and mostly two awesome packages. These are really cool, Gensim and NLTK packages. You guys might all be familiar with this. And my procedure is, first I clean the data, right? Because in the reviews data set, so these are reviews about hotels, right? In these text files, we sometimes see that, hey, this hotel is awesome. Hey, this hotel has great view. This hotel is horrible. And then suddenly you see page 1 divided by 20 or something like that, right? Or hit the button to move to the next page or something like that, right? So that is the veracity of big data, right? That's the dirty part of data. So you have to observe that is actually not a review somebody left on a hotel. It's just like a noise that is accidentally accidentally extracted into the data set. So you have to remove those nonsensical, dirty parts of the data. Step 2, you have to remove the stop words. Now, stop words are, for example, I, you, he, she, it, am, is, are, a, an, or, and, you know, words like this. The words that do not really alter the meaning of any sentence, right? And that are used all the time, like all the sentences, regardless of saying I love this hotel or I hate this hotel, should start with the letter I. That's why you remove these stop words. And you tokenize. This is very simple. It just basically means to decompose a sentence into separate words. And we stem the words so that friend, friends, friendship, friendly, friendliness, all of these mean the same thing. So they're all collapsed into the root, which is friend, and then we fit the LDA model. So the model discovers the following topics. Now this is the really magical part. As I said, I only had hotel reviews, and I just applied these steps, and I fed it into the Genskin package in Python. Now the discovered topics are, let's try to infer what these topics are. So topic 1 that this algorithm discovered is a distribution over the words rate, property, charge, per, pay, fee, upgrade, and whatnot. So what could this topic be, according to you guys? Any guesses? This is actually an easy one. This could be basically prices and charges, right? Because this is all about like price, property, charge, upgrade, like they upgraded my room for free and stuff like that, right? So topic 2 is told, said, wait, manager, that manage is probably manager, left, charge, smoke, bad. So this might be communication. Like they told me this, they said me this, the manager told me that, stuff like that. And third one, square, central block, New York City, York, subway, distance within, easy, station. So this could be like proximity to like transportation points, right? So 6 could be, let me go over it real quick. Casinos and nightlife. 7 could be, this is a little ambiguous, but this could be the view of the hotel room. 8 could be family, right? Kid, family, bedroom, children, car, kitchen, adult, daughter, son. This is definitely family. So you are seeing that this, like these words that are so meaningful when they come together, they really mean something. They are discovered by this highly mathematical model, but you don't actually have to code all that math. You can just clean your data set and feed into Python's Gensim library, which is very handy, and these will be basically discovered. So let's classify just 2 reviews, and this is my last slide. I see that the small data is coming, which is more dangerous than big data. So I just made up these 2 reviews, right, just to see how the trained model would score them, would kind of classify them, right, would label them. So review 1, I just made up these sentences. I said, this place is not as big as MGM or Bellagio, but it's a perfect casino. They have great drinks and the food is awesome too, so you can have a nice dinner there. I had fun at this amazing place. And when we score this, when we feed this into the model, we see that the resulting topic distribution that the algorithm thinks that have generated this this piece of text are topic 4, 6, and 9. Let's see what these 4, 6, and 9 are. Food and fun, casinos and nightlife. What was the other one? 9, which is feeling an impression of casinos. I mean, now, if this is not magic, what is magic? Let's look at review 2. We went to this hotel on my husband's vacation as a family. They have a shuttle service to pick you up from the airport. Otherwise, it would be difficult, especially with the kids. Now, the model says this is associated the most with 5 and 8. 5 and 8 are transportation and family. When you look at the review, it really is talking about transportation and family. So this is the magic of generative models and LDA topic models in general with a gentle application. And thank you all for listening to me.